Never standardized, industrial railway locomotive design tended to favor 4 or 6 coupled saddle tanks for many tasks. This configuration gave easy access to the inside motion for maintenance, simple tank removal for boiler work, and an adequate water capacity for short-haul duties. The firm of Manning Wardle was formed in 1858 out of the collapse of E.V. Wilson's railway foundry in Leeds. Using some of Wilson's basic designs, Manning Wardle developed an excellent range of saddle tank engines for civil engineering contractors and industrial users. Manning Wardle L-Class Sir Barclay was built in 1890 for the contractors Logan and Hemingway, but in 1935 she was sold into the ironstone industry. She is seen here outside the shed at Byfield Quarries in Northamptonshire in the 1960s. Despite the homemade cab, her antiquity of design is apparent. The key design feature of note is the large raised wagon-top type firebox, giving excellent steaming capacity, and the simple but robust inside cylinder construction, enabling the engine to withstand really hard work and rough conditions. Manning Wardle's 4 and 6 coupled designs were popular for the rugged conditions of contract work and quarrying, their excellent build quality standing them in good stead. Appalling track, steep gradients and heavy loads that would have damaged more refined designs were normal conditions for industrial engines. A 6-coupled 15-inch cylinder Manning Wardle design was chosen by Birmingham Corporation Waterworks in 1895 for their giant Elan Valley Railway. Calatir and Rinant worked the opening day Royal train up the line's extreme gradients, before being sold to Lloyd's Ironstone at Corby in 1912. The engines joined a 16-inch sister Manning Wardle engine, and Calatir is seen here in the 1960s, being drawn out of what had now become Stewart's and Lloyd's Minerals modern loco shed at Gretton Brook, Corby. Rinant is seen here at work on a plate layer's train, a typical duty in later years, approaching Gretton Brook Lane crossing and then running light towards Brookfield sidings. The type was so successful that it became the basis for almost all future steam locomotive designs at Corby's quarries. The engine coupled to Calatir is the final development of the Manning Wardle design by their ultimate successors Robert Stephenson and Hawthorns. The giant and brutally powerful 18-inch cylinder 56 class, built in the 1950s, still shows the wagon-top firebox boiler design and robust construction. Between the two extremes there had been an excellent intermediate 16-inch cylinder example, which incorporated the same design features and qualities. These engines were built by Manning Wardle and their immediate successor Kitson's, and finally by Robert Stephenson's between 1921 and 1941. They were superb quarry engines and thrived on hard work. However, these locomotives were quite small by the standards of the 1940s, as can be seen here at Buckminster, where number 55, transferred from Corby, passes behind a 1941 18-inch pre-austerity Hunslet. 18-inch design had some characteristics of the austerity type that Stephenson's had built for the Ministry of Supply, but retained the Manning-Wardle heritage in its boiler and was believed by crews to be more powerful. At Corby, they were expected to haul trains of more than 500 tons on a network that stretched up to 7 miles from the works. Here, an 18-inch engine is assisted by a 16-inch example as it approaches Gretton Brook Lane crossing with another heavy load of ore for the furnaces. Manning-Wardle's design principles proved to be very sound, serving industrial railways for over a century. Industrial networks. Industrial railways varied from short private siding systems serving gasworks or power stations to longer colliery or ironstone systems that resembled main line locations. Not all were located in urban areas and were often very attractive places to visit. Many industrial railways, like the system at Bath Gasworks, were very limited in size, but carried an intensive amount of traffic. A 1928 Avonside 040 saddle tank is being employed here on what were essentially shunting duties. Other systems were much longer and had arduous gradients, like the Baddesley Colliery system in Warwickshire. Baddesley used this 1937 Bayer Peacock 4-coupled Garrett William Francis to work the very steep line linking the pithead to the sidings on the Trent Valley main line. To prevent breakaways, the Garrett was always at the downhill end of the rake, which prevented runaway wagons tearing across the busy A5 crossing at the foot of the grade. An even more substantial system was the Lambton, Etten and Joycey Railway, centred on Philadelphia in County Durham. This intensively used system utilised large 062 tanks of main-line proportions and ran trains with brake vans between collieries and staithes on the River Wear. The loco sheds and workshops were at Philadelphia itself, and all the locomotives on the system had cut-down cabs to clear the narrow tunnel leading to the staithes. The 062 tanks built by Kitson's and Robert Stephenson's resembled designs used on South Wales railways, one having originated on the Taff Vale line itself. These engines worked Lantern, Etten and Joycey railway through trains over British rail metals. Short-haul work was undertaken by 060 side and saddle tanks. Even the shed coaling stage was of main line proportions. Only a few miles away at Seaham Harbour, coal was also loaded into colliers from elevated staves. The clearances under these staves ensured the survival into the 1970s of one of the oldest locomotives in service in the UK, an 040 saddle tank built by Stephen Lewin of Poole in 1863. Sporting a highly individual cab and raised dumb buffers for modern wagons, this diminutive engine looked at home against a chaldron wagon that could have been hauled by locomotion number 1. Taking on a rake of modern hoppers was a real David and Goliath spectacle. A distinctly atypical but superbly functional series of industrial locomotives worked in the Stanton Ironworks itself. These were 040 crane tanks and were intensively used to load and unload the work's main products, tubes and fittings, to and from wagons for shipment or storage, and to shunt them around the site. Their build was similar to Stanton No. 34 by Andrew Barclay and was superbly suited for their work on this busy system. Their drivers were highly skilled, but it has to be said that their 2-ton load limit was challenged at times. Not all ironworks were huge. The Kettering Coal and Iron Company's furnaces alongside the Midland Main Line drew their ore direct to the furnaces from the quarries by a 3-foot gauge network reaching out into the Northamptonshire countryside for 3 or 4 miles. The system opened in 1878 and almost unbelievably continued using its original equipment with some modern additions until closure in 1962. It was a railway system in a time warp, using Manning Wardle 060 and Black Hawthorn 040 saddle tanks to haul wooden side-tipping wagons carrying around 2 tons of ore apiece. The ironworks itself closed in 1959, and ore was then transferred to standard gauge wagons at the works site. On arrival at the works, the main line engine would slip its coupling and pull ahead, which would allow one of its brethren to push the rake over the former calcine bays where the ore was transshipped. Ancient black hawthorns mainly shunted at the furnaces, but after their closure went back to main line work. There was almost no shelter for the crew, and the passage of an octogenarian engine and wagons in the middle of a field was somewhat unusual in the swinging 60s. Finally, in a characteristic scene, Kettering Furnaces No. 8 heads past Chestnut Tree Loop. Not all narrow gauge systems were archaic. The 3-foot 3-inch or meter gauge system linking Findon quarries with Wellingborough ironworks was totally modernized in the 1930s. Two new Peckett 060 saddle tanks were supplemented by an even larger similar engine in 1942. The track was relayed with heavy flat-bottom rail, and a new fleet of 98 10-ton skip wagons was introduced to expedite the crane transfer of ore. The line had exceptionally heavy gradients and extremely forceful workings required. In addition to climbing to the quarries, there was a steep grade against the load. One of the 1934 Pecketts brings 4 skip wagons of ore out of No. 6 quarry. Another modern 2-foot 6-inch narrow gauge system built in the 1920s linked Lloyd's, later Bowater's paper mill, and Riddham Dock on the River Swale. Due to the fire risk, engines carried spark arresters, centre buffer couplings, electric headlights, and hauled modern bogie rolling stock. There were even 2 fireless engines. Due to the lack of road access, workmen's trains were also run, and the line worked 24 hours a day, 7 days a week. Paper for export was loaded directly for shipping, but a time and motion study condemned the railway to closure in 1969. Part has been preserved as the Sittingbourne and Kemsley Railway. The Oxfordshire Ironstone system linked quarries on the dip slope of Edge Hill with the GWR at Banbury. By the 1960s, it resembled a main line in many ways. Its 4-mile line up to Roxton was double-tracked and signalled, and was worked by 6 coupled locomotives fitted with vacuum brakes and tailed by a brake fan due to the heavy gradients. The ore was brought the 2 miles from the quarries in 15-ton side-tipping dump cars to the crusher at Roxton, this duty usually being carried out by 4 coupled engines fitted with Buckeye couplers. The quarry engines were shedded at Roxton, and there was another shed for mainline locomotives at Pin Hill Farm near the Great Western Railway junction. As yet another train of empties fights upgrade into Roxton Yard, an ex-GWR brake van is run down onto the rear of a loaded train of ore leaving for Banbury, as more ore awaits dispatch to locations in South Wales, Wrexham, Staffordshire and Yorkshire. Up to 50,000 tonnes per week is transported at peak output. Dieselisation came in 1965, replacing the system's 22 steam locomotives, but was followed by complete closure in 1967. Fit for purpose. Whereas a main-line railway could select the best route between its endpoints, industrial railways often had to connect to a fixed location, such as a mine or quarry. Frequently, these were located high above the nearest valley-hugging main line, and ingenious solutions were required to cost-effectively overcome the difficulties that this presented to railway access. Kilmersdon Colliery was located near Radstock in the Somerset coalfield, some 150 feet above the GWR Bristol-Frome line, and opened in 1877. To overcome the difference in levels, a locomotive-worked line ran for about half a mile from the pithead to a self-acting cable-hauled 1-in-4 inclined plane. Full wagons were brought from the pithead by the locomotive in use and shunted to the incline head, which was protected by Scotch blocks. Wagons were attached to the cable, whilst an empty wagon below was also attached. The scotch was removed and the wagon started its descent, hauling the empty up. The lower portion of the incline was single track, followed by double track to the summit so that the wagons could pass. On arrival at the incline head, the wagons would be collected by the engine and taken up to the pit head for loading. In 1912, the Staveley Iron Company acquired rich deposits of iron ore at Hanging Horton and at Scaldwell, near to the London and North Western Railway Market Harborough to Northampton line. Two separate 3-foot gauge systems were established in 1914 to extract the ore, seen here being loaded by an RB34 dragline into wooden side tippers headed by a Peckett 060 saddle tank in Halkett Pit. The 3-foot gauge line then carried the ore the 1.5 miles to Scaldwell along a very rural route, literally following hedgerows. At Scaldwell, Lamport backs its train onto the Tippler platform to enable the ore to be transferred to standard gauge wagons. At the same time, one of the Bagnalls propels a rake of side-tipping dump cars over the Brixworth Road crossing toward the Tippler. In the background, the narrow-gauge sheds and ropeway Tippler site can be seen. dump cars are positioned under the tippler and tipping commences. The impact on the dump cars can be seen as over 2 tons of ironstone crashes down about 20 feet. At Scaldwell Shed, the Peckett has its fire cleaned and is cold, ready for the afternoon turn. Lamport originally worked at Hanging Horton, but joined its twin Scaldwell in 1942. Down at the standard gauge Lamport sidings, the dump cars of ore are blasted up the 1 in 20 gradient of the calcine clamps by Lamport No. 3, where it will be burnt for almost 12 months to remove impurities. Here, Robert runs light up the 1954 standard gauge line to Scaldwell. In 1942, Lamport had run along the parallel road on short lengths of track to transfer to the 3-foot line at Scaldwell. Finally, Robert is seen climbing from the Horseshoe Curve up to the A508 bridge on the steep 1942 line to Hanging Horton. It had all been quite a feat of ingenuity and engineering. Industrial variety. Industrial railways provided a very different working environment to that of the main line. Footplate crews needed high levels of flexibility and special skills directly related to the purpose of each system. This was reflected in the major contrasts between systems, for example that of the very rural Wissington Light Railway, built to serve a sugar refinery, and the plutonic environment of the giant Beckton gasworks system in London. Beckton Gasworks was built alongside the Thames in 1870, with Thames quaysides for the import of coal. It was the largest in Europe, covering over 500 acres and employing over 6,000 workers. The works also had an associated chemicals plant, whose locomotive sheds are shown here. The 1892 Nielsen-built 040 tank engine shows the characteristics of Beckton engines: open cab, cut-down loading gauge, dumb buffers, short wheelbase to negotiate extremely sharp curves, and a cable enabling remote uncoupling from the footplate. Number 13, a 1918 Hawthorne Leslie, negotiates one of the extreme radius curves, while the conditions illustrate the need for the excellent visibility from the open footplate, something that disappeared on main lines half a century earlier. The next tasks are discussed before the loco moves off. The chemical plant used 15 locomotives. The coaling and watering facilities at the shed can be seen in this high-level view as the engines arrive for a crew break. The whole system had over 70 miles of track. Conditions in the gasworks itself were much grimier, its fleet of up to 40 locomotives boasting roundhouse accommodation as seen here. Number 13 in the works fleet follows a saddle tank into the shed before emerging, hauling number 1. This engine is unusually equipped with outside Stephenson's link motion, which can be seen in action as it is returned to the shed. During the First World War, due to shipping losses from the West Indies and lost beet production in Europe, sugar supplies were threatened, and in the 1920s the government supported the development of plants like Wissington in Norfolk to process home-produced beet. To provide a rail transport link, it leased the highly agricultural Wissington Light Railway, which linked to the LNER. By the 1950s, motive power consisted of 2 Manning Wardles and 1 Hudswell-Clark 6-coupled saddle tank seen outside the plant yard. Newcastle had apparently recently been overhauled and painted. The suspension compensation beams, a major aid to staying on the track on systems like Wissington, can be seen. The line passed through the antithesis of an industrial landscape. Its major inward traffics in season were beet, coal and lime. Outward went bulk and bagged sugar, molasses and beet pulp as cattle food. During this period, the plant locomotives and railway were intensively used, with large tonnages being handled. The line's major feature was the lengthy New Fen drainage cut bridge, an imposing structure for a light railway. Crews were very much countrymen, and fishing, and even it was said game poaching, were not unknown during journeys. At times the track appeared to be lost in the vegetation, but that did not conceal the frenetic activity in the beet season, at the end of which things ground to a halt for 6 months, everything being left where it stopped, whilst crews took on maintenance tasks. Mainline men would have probably been lost on the Wissington line. As someone commented, it was a good job the engines knew where they were going.